Okay, Assalamualaikum warahmatullahi wabarakatuh and good afternoon. So for this part, the first part of today's lecture, I will just refresh what we have learned on Monday. So I'll start with a summary of what we have learned on the direct and indirect generation methods for different AM variants. Yeah. Okay, so we'll start with direct method first, using balance modulator and also other devices such as band pass filter. Okay, for full AM, what we can see here is in order to produce full AM signal, apart from balance modulator, we'll use amplifier to amplify the gain to EC and also a summer, to sum our double sideband signal, VMT cos omega CT, and the carrier itself EC cos omega CT. Okay, so this is the broad diagram to generate full AM using balance modulator. And from full AM to generate double sideband suppressed carrier, we just remove the EC part. Yeah, so we remove the EC, we just multiply two signals, VMT and the carrier itself, cos omega CT, so it becomes, and this VMT cos omega CT will produce double sideband signals, the upper and lower sidebands. And from double sideband suppressed carrier, if we want to produce single sideband, we just add a band pass filter tune at either FC plus or FC minus FM. So in here, after the balance modulator, we just put a band pass filter, and then output from the band pass filter is our single sideband signal. Okay, so this is direct method using balance modulator. As for indirect method, we can use nonlinear devices or full AM modulators or phase shifting methods. Okay, for full AM, we indirectly we use the nonlinear device and band pass filter. Okay, so after the nonlinear device, will produce not only the full AM signal but also the DC voltage and also the higher harmonics. So if we have our band pass filter tuned at FC and with bandwidth of 2 FM, then all other components that we don't want will be removed. So for double sideband suppressed carrier, we use two full AM, where one of the full AM modulator will receive an inverted of VMT. Okay, and then at our summer here, the upper arm plus, lower arm minus, so output will be double sideband suppressed carrier because the operations, the minus operation below here will cancel out the EC signal. As for single sideband, and with this indirect method, we use balance modulator, but the advantage of this one, instead of the previously balance modulator and band pass filter, is that we remove the need for band pass filter, band pass filter single sideband. So with this phase shifting, there's no need for filtering. So we cancel, we just cancel one of the sidebands using phase shifting method. So if you remember, this operation actually reflects the equation that we, remember the first part where we analyze single sideband equation, where we have the Hilbert voltage, where the Hilbert voltage is actually the 90-degree phase shift of our VMT and also VCT. So this block diagram actually reflects that mathematical analysis. So we have our VMT multiplied with cos omega ct, and then the below part is the sine of our VMT and also the sine of our omega ct. And then for the lower arm, whether it's plus or minus will result in the choice of our single sideband, whether it's lower sideband or upper sideband. If it's plus, then we produce lower sideband. If it's minus, we generate upper sideband. So these are the just summary of what we have learned on Monday. Okay, so before I proceed with the modulation part, I want to share final exam questions, yeah, so that you can get an idea on the points there, or the parts that maybe you can pay attention to during the lecture. Okay, so actually this is based on 3 final exams last 3 semesters. So the first one is 2018-19 semester 2. Okay, so if you look at this question, okay, so the question asks stated balance modulator is circuit that generate or detect double sideband full carrier, double sideband suppressed carrier, or single sideband signal. The first part B, sorry, A, we have already discussed before, yeah. So this is the second part on the generation and detection. So, and then the output of balance modulator can be further processed by filtering. So, and then using the concept of balance modulator, filter, local oscillator, and amplifier, draw suitable block diagram for generating double sideband full carrier, double sideband suppressed carrier, and single sideband. Show the output based on mathematical concept. Okay, so this actually I've shown just now, right? The block diagram using balance modulator and filter, okay, to produce full AM, double sideband suppressed carrier, and single sideband. So mathematically, you could just derive based on the block diagrams operations. From there, you can derive and just multiply the signals, input signals to your balance modulator, and wherever you have the summer, etc., you just apply that. So despite mathematics, it's also quite simple. Okay, you can refer to the slide because it's there. And then part 2, balance modulator has been used for the circuit detection of these 3 variants. Using mathematical concept, show how the modulating signal can be obtained. Okay, this one I will show later in the next lecture. So, but in our slide, we just show how to detect suppressed carrier and single sideband using balance modulator. But the same step, exactly the same step, can be applied for full AM. And using mathematical analysis, discuss the effects of phase shift of phi and delta F on the detection. Okay, this also can be found in the slide. I'll explain later. So we know, yeah. So in next topic, we can sense the importance of detection using balance modulator, and we can also see the effects of phase shift during detection using balance modulator. Okay, so these 2 and 3 I'll explain in our next lecture shortly. And then this one, 1920 semester 1. Okay, if you remember, we have already solved the B123, to calculate the power, etc. And now is the design part where you need to sketch the block diagram. So it says design full AM transmitter using balance modulator and other suitable components. So again, yeah, very similar to the previous semester. So it's also in the slide, but in here, since the values of VCT and VMT are given, so you need to label them in your diagram. Okay. And then part C, the same semester, you are given this diagram. So your message is double sideband suppressed carrier. So it uses synchronous detector. So this is detection part. And then for this type of detector, local oscillator is required to generate a local carrier, omega CT plus phi. Okay. So derive mathematical expression of low pass filter output if the local oscillator successfully generates local carrier. So successfully generate local carrier is when the frequency generated at LO here at the receiver is the same as in transmitter. So in transmitter, we do not have this phi term. So it's only cos omega CT. So supposedly at the receiver, this phi is equal to 0 lah. So part 1 is when your phi is equal to 0. Yeah. Okay. So just down here. So for this part 1, your phi should be 0. Okay, so you just derive mathematically. And then second, show the implication if our phi is equal to pi over 2 or 90 degree. Okay, so this one I will show it in my next explanation at the demodulation or detection part. So this one, instead of just cos omega CT, it has a phase shift of 90 degree. Yeah. So what will happen to your output? Okay, this one we'll study next. Okay, so let's look at the other. So this, what I can notice in this 3 last semesters, they all focus on balance modulator. Yeah, but we cannot guarantee that this year other types of receivers won't come out, because the envelope detector, for example, had been asked. I can't remember, but it was asked before. But balanced modulator is obviously more popular. Okay, here also, this is last semester where we have this online session. 2019-20 semester 2. So again, it's balance modulator. At this time, you're given what is VA and VB. Okay. So you need to derive the expression at point C. So to derive, you have to multiply lah VA and VB. And then identify the type of modulated AM at C. And then you need to sketch the spectrums at point A, B, and C. Okay, this question is quite nice because what you have learned in the first part, the concept part, is applied to the generation and detection methods. So, and then 3, discuss 2 advantages of what the AM signal generated in here. So from here, you know that it's a double sideband suppressed carrier lah, from the block diagram here. It's a double sideband suppressed carrier. So what's the advantage? 2 advantages of double sideband suppressed carrier compared to full AM related to power. And then illustrate the block diagram of AM modulator using the balance modulator and additional device that reduce the bandwidth. Okay, so from the double sideband suppressed carrier, you need to add additional device so that it can further improve the bandwidth performance of our double sideband suppressed carrier. Okay, so you know what it is, obviously, and then identify. You need to add this device, additional device, and identify what this new type of AM signal, and derive if the upper sideband is chosen, illustrate the frequency spectrum. Okay, from this part 5, you also know that what type of this new modulated AM signal. Okay, and then that part is on the modulation or generation. And then this here, part B is on the receiver or detection. So it says, illustrate block diagram using balance modulator and additional device that can extract back the modulating signal. So this is the detection part. So, yeah, so you need to come up with the block diagram for the detection, of your double sideband suppressed carrier signal. And then you need to derive mathematically the output of your generation detection like block diagram. And then finally, super heterodyne technology. Okay, so after the generation and detection of full AM signals, I will touch on this super heterodyne technology because this is the practice, what has been practiced commercially, the super heterodyne. So, but the block diagram and operational principles, as explained in the slide. Okay, so this is the some of discussions based on final year exams, so that when I give my lecture next, you can sense the important parts that you need to focus on. So, but envelope detector is also important, because it has also come out. So even though it has not been asked in these 3 semesters, but it might, we don't know yet for this semester. So, okay. So I want you to submit as your homework this part, final exam 2019-2020. So this I will assign as your homework. I'm sorry. Okay, this will be your homework. Oops. But don't worry, the due will be next week. So some of the questions you already know from previous lecture. It's just the detection part, and that maybe you can get the answer from my next lecture. Okay, so that's it on the final exam discussion. Okay. So I'll continue my lecture for the detection part. Okay, I'll just stop first.